Hi, everyone. Thank you for joining today's Lunch and Learn on the fundamentals of instrumentation and controls overview. My name is Xiu Lu, and I am the Process Safety EIT here at Risk Life, where I also manage our training courses. So today's agenda includes a presentation by David Clark, one of our experienced course instructor. And today we'll cover what is instrumentation and controls, why instrumentation and controls matter, an overview of the course, including a preview of its content, a look inside at some of the key topics covered, the course outline, and the guidance on who should attend. David, I will now pass it over to you to introduce yourself and get the presentation started.
Okay, thank you very much. Yeah, my name is David Clark, and just as a brief introduction, by training, I'm an electrical engineer, and I've been working in industry for a little bit over 40 years. And in that time, I've experienced lots of different things. I kind of started out actually in the thermal power industry, involved in design, commissioning, and startup of thermal power plants, both in Alberta as well as in Ontario with Ontario Hydro. Um, Starting out in electrical, was working with, substation design and 132,000 volts. And early in my career, I kind of migrated from that into instrumentation controls because I kind of like 24 volt DC better than 132,000. And so most of my career has really centered around this topic of instrumentation controls, or sometimes I like to call it automation. I moved out of the thermal power industry into oil and gas. I lived and worked in Fort McMurray for Syncrude for about 8 years, and again on site working directly with operations and maintenance on small management of change projects as well as consulting, all in the area of instrumentation controls. If you've if you've lived in Fort McMurray, you know it gets kind of cold up there. So along with the family, we decided to move somewhere warmer and we moved overseas to Saudi Arabia. And I spent about 5 years over in Saudi Arabia, having really a very good experience, both professionally and culturally. Doing a lot of consulting in the area, more in the area of the control system side, a little bit less on the instrumentation side for major mega projects that were uh, being executed at that time. Returning to Calgary, I worked for a company called Colt Engineering, which was later purchased by Worley, right? And I continued to work in the design side on instrumentation controls, and then kind of migrated into more the management of the automation department and general engineering management and project management. But instrumentation controls was really the core of my career over the last 40 years. And now I am, to be honest, semi-retired. But one of the things I like to do is teach courses because it gives me a chance to just share some of my experiences, give back a little bit, continue to meet new people. This particular course on instrumentation is one that I developed for Risk Alive, and so it's one that I particularly like to teach. So instrumentation controls. Most of you probably have some idea what it is. If you've got any exposure at all to P&IDs, you look at a P&ID and there's bubbles all over the place because instrumentation and controls is just integral to all of our processes. And I should say this course is not just for oil and gas. I mean, if you're in oil and gas or you're in thermal power, or even we've taught it in a pharmaceutical, in pulp and paper, in mining industry. Really, instrumentation controls is the same kind of regardless of what industry you're in, right? So we know the importance of process measurement because we're measuring what's happening in the process, whether it's flows or levels or pressures or temperatures, even the fluid properties like maybe density or pH or various other things. And then we need to try to control those things in order to have an efficient operation and for your facility to make money, right? So regardless of kind of what your job is, I mean, maybe you're in design, maybe you're in operations or maintenance or safety, just knowing and understanding instrumentation controls is going to just help you do a just do better at your job, right? Now, Risk Alive is very much a safety company. So how does this course on instrumentation controls relate back to safety? Well, Ken Bingham was kind of the founder of this company, and he kind of said that if you look at all the safety functions in your facility, probably 50% of them revolve around instrumentation, right? But if you turn that on its head, it also means that when something goes wrong and we have a process incident, 50% of the time is due to a problem with instrumentation. Okay, so that means that instrumentation controls is absolutely integral to having a safe plant. Okay, so that's part of why we want to learn more about it. So I'm going to just open up the course a little bit, and we're going to take a peek at a few of the actual slides. So this is the course that we're talking about, and essentially it's a 2-day course. And let's just see if that's going to go for me. Okay, what are some of the learning outcomes? Well, first of all, when you finish this course, you should be able to describe and compare a wide range of technologies that we use for measurement. So whether we're measuring process or temperature, level or flow, what's the difference between a vortex meter and an orifice meter and a mag meter and a Coriolis meter? You'll be able to understand that and kind of know the pros and cons of them. We'll get better at reading the P&IDs. So if you took the P&ID course, or if you have some experience with P&IDs, there's going to be some review, but that's always good, just to make sure that we have a good understanding, and then we start delving deeper into it. Control valves. These are important in how we control our process. We're going to look at other final control valves, but we'll spend a little bit of time on control valves, not to make you an expert in sizing them, but what goes into it. And even more importantly, what can go wrong. Okay, we want to look at how things fail as well as how they work, right? Then we'll get into the control system side, and I want you to know and understand some basic control system theory. Now, don't get scared, right? I mean, maybe in university you learned about Bode plots and Nyquist plots and Fourier transforms and Laplace transforms and all that math is all stuff I forgot long ago, right? Well, we really want to look at it from a practical point of view. When you're out on the plant floor or you're walking into the facility or you're in a design review meeting, how does that controller actually work? What is the theory behind it? But presented in a very practical, understanding way. We've got some simulations that we can look at and see how things can change, right? So once you've done this, you should be able to effectively participate in project meetings. So maybe you're part of a design review, or you're going to a process hazard analysis or HAZOP review, you startup planning, operations meetings, all sorts of things, whatever you need to do. Now you've got that literacy to help you understand what's going on and to be really able to more meaningfully communicate. Many times we have multidisciplinary teams. Maybe you're in project management and you wonder, what the heck do those I&C people do all day? This will help you understand that, right? Or maybe you're running an E&I shop and you're on the electrical side, but you got instrumentation people reporting to you, really help you understand what other people are doing. And of course, we want to spend some time looking at the safety side of things, right? Because we often just look at the instrumentations. Yeah, we want to keep our plant running properly and efficiently and making lots of money. But as we said, the other side of the coin is they're required for safety. So we're going to look at them from the point of view of safety instrumented functions as well. So once we've done the course, these are the things that I expect that you'll know. So I kind of look at this as a bit of a boot camp, right? I mean, many of you might be kind of in the situation I was where, there's no engineering degree in instrumentation controls, at least here in Canada. There is overseas. And so we tend to kind of learn on the job, right? And sometimes that takes a long time. So I look at this as a bit of a boot camp, right? We just give you all the fundamentals in two days. You might not remember everything, but you've got a basis on which to move forward. So here's a few things that we're going to look at. We look again from a safety perspective. Sometimes we talk about layers of protection. And one way to present this is with an onion diagram. And it really starts with our process people design an inherently safe process. That's our starting point. And then we wrap around that my basic process control system, maybe not my DCS, PLC, whatever it might be. And its function is to keep my process within what we would call a safe operating envelope, right? Keep everything safe, keep everything operating, keep everything happy. And then the next layer around that revolves around alarms and operator intervention. So if something is starting to go a little bit out of spec, we get an alarm, the operator can intervene, get things back where they're supposed to be. But sometimes there's not time for that. And so that's where we wrap around our safety instrumented system. So when things are starting to get out of control, the safety instrumented system isn't there to keep me operating, it's there to keep me safe. And so many times the safest thing to do is to trip or shut down the plant so that we're safe and then we can figure out the problem and get back to operating. And then the next layer looks at mechanical protection, like things like PSVs and rupture discs and things like that. So these layers here are really what we talk about as preventative layers. And the course primarily is looking at these layers because we want to prevent some kind of an incident from happening. Now, just to complete the diagram, we have, if something happens, we now have mitigating layers. So things like physical protection. Maybe we've got dikes around vessels in case the storage tank leaks or something. And then beyond that, of course, there's an emergency response plan. Okay, what's the plan to get the fire department, communicate with the nearby communities, all those kind of things. But we're going to focus on those preventative layers around process control, alarming, safety systems, and relief devices. Now, just to continue, and we're just kind of taking little snapshots through the course to give you an idea of what we're going to talk about. We will spend some time on the symbology. And again, maybe this is a bit of review, but it's kind of fundamental to be able to read our P&IDs is to understand the symbology. So this slide comes directly out of ISA 5.1, and you'll notice the 2024 version. So it's been fairly recently updated, but that shouldn't scare you because the updates are more tweaks than huge. So if your plant was done made 20 years ago, you're probably going to find that this symbology is 95% the same. It's simply been modernized a little bit. So we'll go through that, make sure that you feel really, really comfortable with the symbology. And then we'll spend some time on, well, we'll talk about pressure, we'll talk about temperature, they're relatively simple, and then we'll talk about level. You know, do you know how many different ways are to measure level? Well, we don't cover everything possible, but we cover a lot. We'll talk everything from level gauges to ultrasonic, radar, capacitance, nuclear, temperature, even floats, displacers, differential pressures, bubblers, load cells. Your facility probably doesn't have all of those, but you would have some of them. And depending on your facility and their age, we try to cover all the basics, right? And, you know, well, which one is the best? Well, there's no answer to that. There's not one that's best. It all depends on what you're trying to measure, why you're trying to measure it, what kind of accuracy you're looking for, and then you pick the one that's right for your application. And then when we're looking at it from a HAZOP or a safety perspective, you know, we're looking at things like probability of failure and demand. What are the chances that a differential pressure measurement is going to be giving us an incorrect reading or failing to trip and things like that. And then, of course, if level is complicated, flow has even more to options to look at, right? And so you're sitting in a meeting and they're talking about turbine meters and vortex meters and pitot tubes and you're getting glassy eyed and you don't know which is which or which one is better or what the pros and cons are. That's that's what we're going to cover. So most of the first day follows what we've just just talked about, right? And we really focus on that process measurement and learning the basics. And then we get into things like control valves. Now, a lot of people think, well, they're kind of a mechanical thing, not a big deal, right? But what happens sometimes is we focus on our control system. We've spent $1 million and we've got this very sophisticated control system with all sorts of wonderful software and graphical user interfaces and applications and AI and dynamic matrix control and all sorts of things, right? But the control valve then is the endpoint. And if we neglect that, then all the sophisticated software in the world is not going to keep our loop working properly. So we want to make sure that we understand the field side of things as well as the control system side of things. But we will get into the controls and we look at some basic control system hierarchy. So we're focused on basic regulatory control and safety controls and how they interact here with the process. But we will get into some advanced regulatory control. So we'll talk about ratio control and feed forward and override, some of these other controls that maybe you don't have a lot in your plant, but you're looking at your PNID and there's a feed forward loop there, and you're wondering, what the heck? That looks so different. I don't understand how that can possibly work. This will help you understand that. And we'll have examples and we'll work through it and we'll get a good understanding of those different types of more advanced regulatory controls. Now, just to complete the slide, there's optimization, enterprise level controls. Those are somewhat outside the scope of this particular course. But once we've covered all that, then we look at things like the control algorithms. Remember, I said we're going to do control theory. Most of you have probably heard that, yeah, we have PID control. Well, what is that? Okay, so the ISA standard has a definition of PID control. Every vendor is going to implement it to an ISA standard and then add their own bells and whistles to make their product better than the next one, right? And again, don't be scared by the equation. You say, oh my goodness, I don't remember integrals and differentials anymore. We're going to make it simple and straightforward. We're going to talk about tuning. Okay, what difference does tuning make, and how do we go about that, and what happens if the tuning isn't correct, right? So we'll talk about gain and integral time and derivative time. And again, we just try to make this as easy to understand and as practical as possible because you're out in the facility and on the plant floor. You're not in the office working out integrals and differentials and Bode plots. You just want to know how this thing is going to work, right? And so we're going to cover that and make it clear for you. So once we've done that, then we go back and look at some loops on the PNID, right? And now we know what's inside this little black box here, what it's actually doing. And we look at different failure modes, what happens when it fails, right? Does that valve here is shown as fail open, right? So it's going to fail open, but not, other things might happen, right? Might get stuck. We might get some bad values in our measurement. So we need to talk about those types of failure modes as well as talking about how this loop is going to work. Now, this is kind of the course outline. So I've kind of delved in and looked at specific things here quickly, but the overall course outline is really pretty straightforward. We're going to talk about the basics, right? Things like terminology. What's the difference between accuracy and precision? What does probability of failure on demand mean? What does I don't know, range and span and zero suppression, all these words that can bounce around. What what do they actually mean, right? So we're gonna, cover all the basics and things like that, and just get a good grounding on automation. Then those process measurements we talked about, pressure, temperature, flow, and level, final control elements, control valves, VFDs, even regulators. Then into that control theory, the basic regulatory controls, and then into those more advanced regulatory controls. And then finally, really delve in and explore this topic of safety instrumented systems and safety instrument functions and how do they relate to this whole thing. So that's kind of your course outline and what's in the course. So hopefully you're thinking to yourself right now, "Oh, I wonder if this course is for me. Maybe it would be useful for me, right?" So this little slide kind of addresses that. I mean, who should attend? Well, certainly if you're a new grad or an EIT, it's great to start off with a foundation, right? What is the basic foundation that I need? So whether I'm starting out in process or electrical or instrumentation, it's going to be really helpful for you just to get started. But even for those who've been working for many years, and we've had people in the course who have been working 5 years, 10 years, 20 years, even 30 years, and say, hey, I had some gaps, some things I didn't understand, and now it's a lot clearer to me. So, process engineers, you understand your process, and you need to specify and work with the instrument guys. Okay, now we need to measure some flows and levels. What are we going to specify here, right? You're an I&C engineer or technologist. Let's help you fill in the gaps, right? You work in a particular facility, particular projects, you've learned some specific things, but let's broaden your knowledge so that you understand the whole picture, right? Maybe you're in maintenance. Obviously, this is going to be important to you. Maybe you're on the operations side, and knowing how things fail and how things operate and things to watch out for are going to be really important for you. From a safety, if you're a safety specialist and you're involved with HazOps, and all this talk about instrumentations just hasn't been very clear, this is really going to help you out, right? Project managers, right? What do those I&C guys do? How is that going to impact me? Do you know that the instrument guys have more purchase orders than any other discipline? They buy more stuff, not necessarily spend more money, but they buy more stuff. And project managers want to know what those guys are doing all day. Okay. If you're at planners, we've had planners in the course, right? And they're preparing shutdown plans and project plans and just need to understand what are we installing, right? And so really I would say it's there for anyone who wants to learn. Okay. So that's kind of my sneak preview of the course. Hopefully that piques your interest. And I'll turn it back over to Shayu if
Thank you, David, for the presentation. We'll open the floor for a question now if you have any.
Hey, thanks, David. That was great. I think it's been a long time since I've sat in on one of these course intros, and very good job. Kudos to you and the team to put this together. Fantastic. I have I've got one question for you. What do you think in this course it would be fun for someone to come and actually participate in this course? Like, what's in it for the attendee that might be a surprise to the attendee, or the attendee might find it very interesting? And this would be based on from the hundreds of people that you've already taught. I mean, what would you share with them? What would you tell them that they might be surprised, or it might be kind of fun for them to attend this course just based on your experience?
Well, everybody that comes to the course comes with a different kind of background. And so we always talk about, well, what did you learn, right? And everybody comes away with some different things. But one of the things that I find kind of fun and interesting, and we didn't really talk about, is I kind of polled a number of vendors as we put this together. And as a result, I've got some actual samples. So we won't just put pictures on there. We've got some, if we do it in person, we'll pass them around, and if we're doing it virtually, we'll hold them up to the camera. But if you want to know what an orifice plate looks like, or a control valve looks like, or a vortex meter, or a radar detector, well, we've got samples of all these things. And if we're doing it in person, you can hold it, you can weigh it, you can look at it, or I can display it on the camera. And it gives you just that extra little feel for, oh, okay, that's what that device is. Okay, it gives you that physical feel, right? And I think a lot of students find that really helpful.
No, that's great, David. Thanks.
Okay.
Yeah, I think that puts things in perspective. It speaks volumes to your experience as well as to what you found that was sort of widen the eyes of the participants or the attendees that show up.
Yeah, yeah. Sometimes that physical feel is different than what you see as a bubble on a PNID, right? Yeah.
For sure. Thanks.
Okay.
Thank you, David. We also have one more question from the chat. Can process engineers become experts in instrumentation?
So absolutely. And in fact, INC or automation is very much an interdisciplinary type of discipline, right? Um, I'm an electrical engineer, and often electrical engineers come to the discipline because most of their equipment is computer-based or electrical. Uh, in a past generation, it was primarily mechanical engineers because all of our instrumentation was more cams and levers and mechanical type. But as an electrical engineer, I don't necessarily have a good understanding of the process side of things. And so people who come from a chemical engineering or a process engineering background, they understand much more about the process and what are the control objectives, right? And then you work together with the other members of the team to how do we meet those objectives. So I managed the automation department in Worley for a number of years, and many of our people were electrical engineers, chemical engineers, or they came from the trades. They might be electricians or maintenance people that came up. We've had mechanical engineers, we've even had civil engineers, and all of those bring different perspectives that allow really a better overall team and overall design.
Thank you. Uh, One last question. Can we integrate AI in process control solutions to support operations people during troubleshooting?
So I think the answer is absolutely yes. Not that I have a lot of experience with that. In a minute, we're going to show you an AI application around PHA development. But when you look at things from even a maintenance point of view, and we talk about things like predictive maintenance, using AI to be able to look at performance of loops and be able to say, well, this loop here isn't working well, and what are some of the things that could be wrong? Or operators that are dealing with multiple alarms and just having an AI assistant to say, what do you think could be the root cause and what are some possible actions? As well as just an overall look at, we talk about enterprise control systems, which is kind of getting outside the scope. But if you have a large refinery and you have thousands of inputs and outputs, to be able to gather all that data and compare it historically and start seeing where can I optimize control. I, and again, I don't have firsthand experience. When we think about it, there are so many applications for AI, and I know many people are working on bringing those to bear. And as I say, we'll show you a little bit about what Risk Alive is working on.
Is this course, is there a customization of this course available, or is it just a public course?
Well, we can do both, right? And so we've done private training in two ways, either virtually, where I sit in my back garage and talk to you wherever you are in the world, or I've traveled to different sites, either locally or, even went down to Arizona, to Rio Tinto, and talked to the mining folks, right? What I find though on the instrumentation side is the course is fairly generic in that it doesn't really matter what industry it is. It's the same instrumentation, it's the same controls. But what is nice when we're doing private training is we don't have to talk about a lot of different control systems. We can talk about the control system that they have, and we can talk about some of the process measurements that they have, and maybe we can even talk about some of the problems that they have. So the private training, not so much customizing the course itself, but actually be able to focus on things that are relevant to that particular customer. So if you're close to Calgary, you can come in person, and otherwise, watch me on your screen in your
Yeah.
pajamas.
Yeah. Just one last question for you, David, before.
Yeah.
Does course cover different industries, for example, nuclear power plants, pulp paper, etc., other than traditional oil and gas?
Yeah, and that's kind of what I've been saying is that instrumentation really covers all industries. Now, I haven't taught this in a nuclear plant yet, but the reality is still the same, right? What are we doing? We're measuring process conditions, pressure, level, temperature. I taught this in the pulp mill in Hinton, right? And so even in a pulp mill, well, we have flows coming down a conveyor belt. We've got levels, we've got chemical additions, we've got all these different processes, right? Same in a pharmaceutical plant, right? And as I said, we taught it down in Rio Tinto down in Arizona. So very much it is regardless of what industry you're in. I think the content is very, very relevant. And again, if we're doing public training, we'll try and make it relevant to everybody. If we're doing private training, we can be more specific with your particular process.
Yeah.
And I would say too, more than some other disciplines, it's also very international. You look at ISA, which is the International Society of Automation, and they are the basic standard for all my PNID symbology, and it is recognized worldwide. So whether I was working in Saudi Arabia or working in Thunder Bay, we're using those same standards. Same on the safety system. Safety instrument systems are defined by both ISA 84 as well as IEC 61511, and those two standards have been harmonized, so they're almost word for word identical. So whether we're in Fort McMurray or whether we're in Al Khobar, Saudi Arabia, we're following the same standards. So instrumentation is nice that way. We cross international boundaries as well as process boundaries.
Thank you, David, for answering the question. With that, if we have no more questions, we'll wrap up our session. Again, if anyone has any questions, please feel free to send me an email. Thank you again for taking your time and joining us today. We hope to see you in our next session.
All right. Thank you, everyone.